Hey everyone, I hope you're doing well today. In this video, let's practice factoring polynomials completely. To get the most out of this video, I really encourage you to grab some paper and something to write with, and let's do some math together. Alright, so for this first example, let's go ahead and see if we can factor this polynomial where we have 16x to the third power minus 44x squared. Let's do minus 42x. Alright, so if you want to try it on your own, go ahead and pause, but otherwise let's just go through it together, okay? So right away, looking at these three terms, I see 2 as a common factor, and they all have x as well, so I'm going to factor out 2x as the GCF. We're going to be left with 8x to the second power minus 22x, and then minus 21. Alright, so there's our first part. After factoring the GCF, I'm going to take a look inside here at this trinomial, and let's see if we can factor it. So what I'm going to do is this 8x squared, I'm going to write two factors of that. I'm going to start with 4x and 2x, and then for negative 21, I'm going to start with a 7 and a 3, and let's see what happens if I put a negative on the 7. So if I multiply across, that's going to be negative 28x, that's going to be positive 6x. That does combine to get negative 22x, so we should be good to go. So I'm going to go ahead and set up this 2x in front. And remember, 4x is paired with the minus 7, but actually in the binomial, it's going to be paired with the plus 3 because they're not actually going to multiply by each other. And then the 2x is going to pair with the minus 7 for the binomial. Remember, the pairings are for the outers and the inners, not for the actual binomials. Okay, so this right here would be the fully factored form for this polynomial. So now that we have a monomial and a linear factor with another linear factor, we can't factor anymore. Here's another one. Let's go ahead and try factoring this, let's say n to the fourth power minus 4n squared. And let's do minus 60. So right away here, notice that the powers of this one, this is an even one, so it's a perfect square, and then this is half of it. So even though the degrees are higher, we can go ahead and see if we can factor. So I'm looking at this as, I don't know, I'll write this on the side. This is a trinomial that can be factored maybe. And so we can do maybe n to the second power and n to the second power. And we're looking for factors of 60 that maybe add to get to 4 or subtract to get to 4. I'm thinking maybe of negative 10 and a positive 6. So if we multiply across, that would be negative 10n squared. This would be positive 6n, and that does combine to get negative 4n squared. So let's see, right away we can go ahead and factor this as n squared. And since they're both n squared, doesn't matter how we pair these up, then we're going to have n squared and then plus 6. Okay, so at this point we have two binomials, and you should see if we can maybe factor them anymore, but looking at this first one, this isn't a difference of squares, so that one's done, and we can't do a sum of any type of square. 6 isn't a perfect square, and sum of squares is not a thing either, so this is fully factored at this point. For a third example, let's go ahead and see if we can factor this where we have x to the third power and then plus 3x to the second power minus x and minus 3. And let's see if we can factor this. So remember, when we have a cubic polynomial that has 4 terms, we generally like to see if we can factor by grouping. So what I'm going to do is I'm going to rewrite this. So the first two are going to be grouped as x cubed plus this 3x squared. That's going to be the first grouping. And then we're going to subtract the second grouping. So I'm going to minus, and inside here I'm going to have an x. And then instead of writing minus 3, I'm going to write a plus 3. Remember, if we distribute that minus in front, that's going to make it the same as what we started with. Okay, so super important. Factoring out the GCF of each of these groupings, we can factor out x squared here, and we're going to be left with x plus 3 inside the first grouping. And then for this next one, it's always important to maybe just write this 1 in front so that you can see what's going on, because I can't factor anything else out for the second one, so it's going to be left with x plus 3. Okay. Now the reason why to write the 1 is just so you can see what we're actually grouping. So if we're looking at this whole piece as like a term, right? If we're looking at this x squared plus 3x as one whole term, and this minus 1 times x plus 3 as another term, you can notice that they do have a common factor here, right? So looking at the bottom, you can see, okay, this one has x plus 3 and this one has x plus 3. So if they have it in common, we can factor it out, all right? So we can factor this to being x plus 3. That's the GCF of both of these terms. And what we have left is the x squared minus 1. So that's going to be x squared minus 1. That's going to be what we're left with. And before you think you're done, keep in mind that this first one is done. This is linear, so that can't be simplified anymore or factored anymore. But this x squared minus 1 is a difference of squares. So what we can do here is we can actually factor that, and we can have a final factored form of this x plus 3 in front, just copying that. And what we have after that, this x squared minus 1 becomes x plus 1 times the quantity of x minus 1. So at this point, this is linear, and this is linear. This is fully factored now. For a fourth example, let's go ahead and factor this polynomial where we have negative 4x to the fourth power, and let's take away 500x. Okay, so here is our polynomial. And I think the first thing we could do here is maybe look for a GCF. So I'm going to factor out a negative 4. I think they have a 4 in common as a factor, and they both have one of these x's. When we do that, we're going to be left with x to the third power plus 125. Okay, so at this point, take a look at what we have in front. I think that this negative 4x, that's a monomial that can't be factored, so that's done. However, looking inside here, this is a sum of cubes, okay? So sum of cubes. So when we do that, you should take a look and try to think, okay, what is the cube root of that x cubed? And the cube root of that is just going to be x. And what's the cube root of the 125? And that's going to be 5. So it's important to know what those cube roots are so that we can actually do the factoring, okay? So if you need to look up your pattern, go ahead and do so. If you think you got it in your head, great. The first thing is if it's a sum of cubes, we start with just adding those two terms, x plus 5. It's always the same sign if it's plus. And then we're going to square it, the first term. And it's always going to be the opposite sign for this next one, and it's the product. So 5 times x is going to be 5x. And then squaring, the second term is squaring 5, that's going to be plus 25. So this right here would be the factored version if we have a sum of cubes. Okay, so just to kind of recap here, this first part is a monomial, can't be factored. This is a linear term, can't be factored. And when we have a sum of cubes or difference of cubes, even though this is a quadratic, it can't be factored. All right, so this would be the most factored form of this polynomial. And for a fifth example, let's go ahead and try this where we have 36y to the third power, and then let's do minus 15y to the second power, and then plus 84y, and then minus 35. Okay, so we have a cubic polynomial and it has 4 terms. Again, just like earlier, I think the first thing I would try to do is factor by grouping. So I'm going to try to group the first 2 terms. Let's put this 36y cubed minus 15y squared inside the same grouping. And since we have a plus, we don't have to flip any signs with the grouping in here. So we're just going to have 84y minus 35. Again, if it was a minus in front of the parentheses, that would change things, but we have a plus, so that's pretty straightforward. Okay. Now let's find the GCF of each grouping here. So for the first one, I think 3 would be the GCF, and I think a y squared. So let's take out a 3y squared and see what's left. I think we'd be left with 12y and then minus 5. That should be right. And then for the second grouping, let's see what they have in common. I think we could take out maybe a 7. I think 7's a common factor. So 7 goes into both of these. 7 times 12 is going to be 84, so we'll have 12y. And then 7 times a negative 5 gets you negative 35 here. Okay, so that actually works out pretty nicely for us, right? So if we take a peek and see what we have left over as an entire term, again, this is like one piece because it's all multiplied together, and this is one piece as well. However, both of these terms have this 12y minus 5, right, as a common factor or common binomial. So we could factor that out as the GCF. And if we do that, we'll have 12y minus 5. And then what's left over is going to be this 3y squared plus 7. All right, so this is a linear binomial, can't be factored at all, right? And we also over here have this 3y squared plus 7, and that is not factorable either. So we are all done. So there's 5 examples so far, and let's kind of keep on practicing a little bit more. Hopefully this is helpful. So for a 6th example, let's try factoring something that looks like this. We have 18c to the 4th power. Let's do plus 57c to the 3rd power. And then let's do minus 10c squared. There's no coefficients with common factors here, but all the terms here have c squared, so I'll factor that out as a GCF. we'll be left with 18c squared plus 57c, and then minus 10. This monomial can't be factored, but inside here we have a quadratic, and quadratics, hopefully we can try to see if we can factor. So trying to factor this, maybe I can start with two factors of 18c squared, like 9c and 2c, and then for negative 10, maybe I can try like a negative 5 and a positive 2. If I go across here, that's going to be negative 45 and positive 4, that's going to be negative 41, so that's no good. If I go diagonal, that's 18 and negative 10, so that's positive 8c, so that's also no good. At this point, I'm going to scrap these and try something different. So let's get rid of these, and I'm going to try maybe 6c and 3c. I'm going to try negative 5 and positive 2. I'm going to keep those ones. So if I go across here, that's negative 30, and then here is going to be, positive 6, so that's going to be negative 24. That's no good. Then this is going to be positive 12 and negative 15. That's going to be negative 3, so that's also no good. So we've already tried changing the coefficients, but maybe we can try changing the factors of negative 10. So let's try doing maybe negative 10 and positive 1. And so if we go across here, it's negative 60 and positive 3. That's actually going to be negative 57, so we actually know what to do next here. Instead of making this a negative 10, let's make it a positive 10 and make this a negative 1. So if we multiply, that's going to be positive 60 and negative 3, and that does equal positive 57 rather. Okay, so these are going to be how we're going to write our binomial. So we'll have c squared. And again, the 6c, even though the line's going to the positive 10, it's going to be with the same binomial as the minus 1. And then the 3c, that's going to be in the same binomial as the plus 10. If that's still a little weird, go ahead and factor it. I promise you it'll work. This first term here, the c squared, is a monomial, can't be factored. This is linear and this is linear, so we are all good to go. Here's another example, example 7. Let's go ahead and try factoring 2d to the 4th power and then minus 13d squared, and do minus 45 after that. All right, so let's see if we can factor this. It can't really factor by grouping, and there's no GCF here, but I do notice right away that this 4 and this 2, again, 4 is a perfect square, and 2 is half of it. So we might be able to factor this just like a quadratic, just with higher exponents. So for 2d to the 4th power, maybe some factors here are going to be 2d squared, and then d squared. And then for 45 or negative 45, maybe we can try something like negative 9 and positive 5. 9 times 5 is 45, right? And so this would be negative 18, and this would be positive 5. So that does equal negative 13 if you combine them. So that makes sense, and that works out kind of nicely on the first try. So again, take some practice, but once you get the hang of it, it's a lot more straightforward. So for this first one, we have 2d to the 2nd power. I know the line's going to negative 5, but make sure we put a plus 5 in this one. And then for the d to the 2nd power, that leaves the minus 9 left. Okay, so at this point, we have two binomials. That's kind of nice. And if we look at this first one, this 2d to squared plus 5, this one can't be factored because it's a sum, and they're not perfect squares, so we can't do anything with that. If you want to think about this one, though, this one you can do something with. So if you need to pause and think about it, go for it. Or if you think you know, let's just go right into it. So this first one, we're just going to copy. This is 2d squared plus 5. And for the second one, it's a difference of squares. So if you thought of that, wonderful. That's going to be d plus 3 and then d minus 3. All right, so at this point, this is not factorable, even though it's a quadratic. Linears are not factorable, and this is another linear. So this is fully factored now. For an 8th example here, let's go ahead and see if we can try factoring 32x to the 5th power minus 108x to the 2nd power. All right, so again, if you want to pause and try, go for it. Otherwise, I'm going to start with a GCF here. I do think 4 goes into both of these, and I think they both have x squared. Okay, so if you factor that out, 4 times 8 is 32, and we have 3 of these x's. Oh, 8's a perfect cube, and x cubed is a perfect cube, and I think this would be 25, 6, 7, 27. All right, so this looks interesting. I'm already seeing something. Maybe you are too. This is a monomial, so it can't be factored, but looking at this looks interesting, right? So pause to think about it, or try to think what pattern you might see there. if you had to take the cube root of this 8x cubed, that would then be this 2x. And if you took the cube root of 27, that would equal 3. So these are indeed perfect cubes, so this is a difference of cubes pattern. If you don't know how to factor that, maybe look up like a model there of like what the formula or equation would be, or you can kind of just do it with me here. So the first thing to do is take the cube root of both, so that would be 2x, and you keep the same sign. So if it's a difference of cubes, keep the minus sign there, so it's going to be 2x minus 3. And what the next thing you're going to do here is you're going to open up another group here, and you're going to square the first one. So if you square 2x, that would be 4x squared. And then you're going to add the product of the two. So 2x times 3 is going to be 6x. And you're going to square the last one, which is going to be plus 9. All right, so this right here would be the sum, or rather the difference of cubes once you factor it. Okay, so if you're trying to see if we can factor more, let's think about this. This is a monomial, can't be factored. This one's linear, so that can't be factored. And when we have sum and difference of cubes, you'll have a quadratic here, but it's not factorable. Okay, you can go ahead and give it a try if you'd like to, but I promise it's not going to work. And for one final practice problem, let's try factoring this, where we have x to the 5th power, and then minus 3x to the 4th power, minus 16x, just like that, and then plus 48. All right, so if you want to pause and give this last one a try, go for it. Otherwise, let's jump right into it. Okay, so there are 4 terms. So before we try anything else, remember we have 4 terms. I like to try to factor by grouping. I think that might be a good place to start here. So it's x to the 5th minus 3x to the 4th power. Let's group that. And be careful with this minus sign here, right? This is kind of the one where people kind of get messed up here. We're going to do a minus. The 16x is perfectly fine. But instead of writing plus 48, we're going to write minus 48, because if you distribute that negative, the negative 48 does make positive 48. All right, so just be careful with that. Next, we're going to go ahead and factor out a GCF. I'm thinking of an x to the 4th power here. And if we do that, inside we'll have x minus 3. All right, and then for this next one, I'm thinking about factoring out 16. So factor out 16, and that should be left with x minus 3, just like that. All right, so looking here as a GCF, I think they both have this x minus 3. So then factoring out these x minus 3s from both of the terms, that'll be out in front here. And what we're left with are these terms of x to the 4th power minus 16. All right, so at this point, this x minus 3 is linear and it can't be factored. But if you look at this, maybe pause to think about it and see if this is maybe factorable. If it's not, then we're done. But if you think it is factorable, then we should keep going. All right. If you realize that this is a difference of squares, then awesome job. These are both perfect squares. So let's go ahead and factor that. So we have this x minus 3 out in front still. Okay. And then the square root of both of these, that's going to be x squared and then plus 4. And then the next binomial here is going to be x squared minus 4. All right, so that would be the next factored form. So this is linear, can't be factored anymore. This is quadratic, but there's no sum of squares, so that can't be done. But if you take a look at this last one, see if this one can be factored at all. And if you were thinking, oh, that's another difference of squares, then good job, right? That can be factored just a little bit more. So we have this x minus 3 as our first linear factor, and then we have a quadratic factor next. That can't be factored, right? But that's okay, we just leave it alone. And for this last one, the square roots are going to be x and then plus 2, and then afterwards we'll have x minus 2. So at this point, linear, quadratic, but they can't be factored, and then linear, which can't be factored, so we are all done. All right, so there you have 9 different practice problems on factoring polynomials completely. Hope it helped, and if you found it helpful, let me know in the comment section down below or give the video a thumbs up. And as always, keep up the great work, and I'll see you in the next one.